Okay, so let us start today's session. What we had seen last time was heating effect of electric current. Today we'll be going with the second part of it. Okay, 12.7. So it is 12.7.1, that is practical applications of heating effect of electric current. So last time we saw there is some phenomenon called as heating effect of electric current. In short, it means that heat is produced due to electric current. Okay, we saw one formula how to measure that heat produced, and we saw some other derivations also. So today what we are going to do is, based on that, one thing we already know, that electric current is always going to produce heat, because in electric current always there is energy conversion, and whenever there is energy conversion, it simply means that heat is going to be produced. So that we already know by the name heating effect of electric current. But today we are going to see one of the applications of it. Okay, devices which use this principle. This is a principle, heating effect of electric current. Based on this, there are various devices which we have in our, suppose let's say, daily use. But in our syllabus in class 10th, we have only two devices, one of which you already know, that is electric bulb, and there is some basic functionality of electric fuse. So let us start. So what we have today is, there are various devices available in the market, okay, which utilize heating effect of electric current. But we are going to see only two devices which are there in our syllabus. Okay, only two devices are there in our syllabus. One is electric bulb, another one is electric fuse. So we have to see in detail, because out of these two, one will definitely be asked in the exam. Okay, it might be one marker question, or it might be, suppose let's say, a bigger 3 marker 4 marker question, depends. But out of these, CBSE has always a habit of at least asking one question based on it. Okay, so let us start. So we have two devices. Which one? Electric bulb, electric fuse. In our syllabus there are only two devices. Okay. Now, other devices which are based on heating effect of electric current. See, matlab basically what we have to see is any device which we have in our, suppose let's say, home, which utilizes heat, that is nothing but called as heating effect of electric current. Okay? So basically that's a practical application. Any device which produces heat. Okay? And even the devices which do not. So all those devices comes under practical applications. So other devices which we have at our home and still utilize heating effect of electric current are nothing but these. Which ones? First is laundry iron, okay, the iron which we use. Second is electric toaster, okay, second is electric toaster. Third is what? Oven. Third is oven. Then electric oven. Fourth is electric kettle. So okay, this is called as electric kettle. Kettle is nothing but used for heating water. Okay, you must have seen it. Then we have electric heater. Okay, but I have shown you two images for electric heater. You can see here. Uh, Actually, in the market, whenever you go, these both the things will be called as electric heater. At least in English. Okay, in at least in English, both these devices will be called as electric heater. But generally for this, in Hindi or in Marathi, we have a word called as shegdi. Okay, this is called as shegdi. Generally this is used as a substitute for gas. Okay, LPG gas substitute. This device is nothing but a substitute for it, LPG gas. Okay. Okay, so what other things we have is nothing but this device is generally used in winter season. Okay, this device is particularly used for heating the room. So whenever the temperature drops, generally people utilize it. But in at least in Parbani, we don't have these devices. Regular means it is not available in every home, because our winter is not that much extreme. Generally, these devices are used in places where the heat is uncontrollable. Like, the winter season is uncontrollable, like it is too much dropping, like for example -5 or maybe 10 or even 5 degrees Celsius, 6 degrees Celsius. So at those places you will see this. It's a regular thing. But at least in Parbani, these devices are not that much used, but still some people use it, okay, just to heat the room. So all these devices comes under heating effect of electric current. But generally we are just going to see only two. Which ones? The first two, that is electric bulb and electric fuse. Okay. So the first device which we are going to see is electric bulb. Exactly what is there, that is we will see. The question that will be asked in the exam is how explain how heating effect of electric current is used. Okay, in case of electric bulb, this kind of question will come. So we just have to mention its features and we also need to mention its qualities, some characteristics. So let us start. So basically this is our electric bulb that we already know. This has been taught to you, I think in 7th or 8th grade. Okay? At least basic design of electric bulb that was there in your syllabus. So what is electric bulb? This is the one, this device. It has actually two electrodes, okay, one positive, one negative, and that has to be connected to our particular slot, okay, any plug. So electric heating used to produce light. So basically this device is nothing but it produces heat and then produces light. So what we do is we supply this device with electricity. Due to this electricity, heat is produced. Okay, we heat this particular filament so much that it glows. Okay, so what basically energy we are converting? We are converting electricity to heat to light. Okay, so three energy we are talking about. One is electricity, second is heat, third is light. So three energy conversions are taking place: electricity to heat and then heat to light. So three electricities are present. Sorry, three energies are present. So basically what that conversion is: electricity to heat to light. Okay, that we know. Now, what exactly is actually what we are heating in this place? So there is one thing called as filament. So I have highlighted it. See, you can see it in this particular red color. That is the filament we are talking about. So this filament is nothing but through this we generally pass our electricity. So what we do is we pass this electricity through this particular filament and it heats so much. Due to that electricity passing, what is going to happen is this filament is going to get heated, and due to that heat, it's going to, suppose let's say its temperature is going to rise, and it rises so much that it generally glows. Okay, so what we are doing is we are heating this particular filament. All we have to do is pass electricity through it. That's it. So first thing, there are certain conditions that this filament material should, at least satisfy. We cannot use any material in place of filament. There are certain characteristics which this particular filament should fulfill. Only then we can use it. Otherwise, any material is not possible to be used as filament. So there are certain features. The first feature that filament should have is it should retain as much heat as possible, because basically what we are doing is we are heating it and only then it is going to glow, right? So this material should be able to retain heat. Retain heat matlab kya? It should be able to hold heat. Otherwise this whole heat is going to go in the environment and then it will not glow because it is not sufficiently hot. So what we have to do is we have to take a material which is going to retain this heat. It should hold that heat. Only then it should be able to glow. Okay, that is the first condition. And second condition, so that it's getting very hot and emits light. So basically why we need a material which retains heat? Because only then it will get hot and only then it will glow. Okay, so we want a material which can hold heat. That is the first feature. Okay, now second thing, must not melt at high temperatures. Obviously it should be a material which should not melt, okay, at high temperatures. See, basically any material will melt, but problem is that we should select a filament in such a way that that particular material should have high melting point. It should not melt, because basically what we are doing is we are heating this filament, right? And if a material melts at just low temperature, then always it will be necessary for us to replace this filament. So what we do, we select a material in such a way that it can withstand high temperatures. It will not melt. So first feature is it should retain heat. Second feature is that it should not melt at high temperatures. Okay, that these are the two features. Next thing, now how to select a material. Okay, to select this filament material, how to select? So we basically have two features. One is retain heat and second is should not melt at high temperatures. So basically we need a strong metal. Okay, why we are selecting metal only? Why not non-metal or alloys? We are selecting metals because only metals have high melting points. Okay, the highest melting points are available with metal, so we will use metals. Another point, it should have high melting point, that we already discussed, so no need. Now we are going to use tungsten in this place. Okay, basically you can use any material. Okay, you can use iron, you can use copper, you can use any metal, but the material which is best suited for electric bulb is tungsten. Okay? So there are also bulbs available in the market which are based on some different metal, but basically which kind of filament is being used? Tungsten. Okay? So this is one particular metal, so this tungsten is used. Now melting point of this particular material, that is tungsten, is 3380 degrees Celsius. See, okay? So this is given in your book, so you have to remember this temperature. In the exam they might ask you for one marker, what is the melting point of tungsten? Okay? So you have to remember it, 3380. I have not given this fact as for the fun. Okay? This is not some extra syllabus, you have to remember it. Melting point is 3380 degrees Celsius of tungsten. And you can see our normal temperature, boiling point of water is nothing but 100 degrees Celsius. Compare that number to this, it's too much big. 100 of water, suppose let's say boiling point, and melting point of tungsten is 3380. So you're talking about a material which can withstand lots of temperatures. Okay? 3380 is a big number, so it's a good material for filament, perfect material. Now next thing, filament, it should be thermally isolated as much as possible. Okay? What you can see here, what we have done is we have isolated it. We have put a glass covering over this particular tungsten material. And why we are isolating it? In terms of what we are isolating it, we are thermally isolating it. Isolate matlab kya? To keep it separate, that we know. What is the meaning of thermally isolated? Thermally isolated means isolation, separation in terms of heat. Suppose let us say it is getting heated, right? That we know after passing electricity. Now if we didn't had this glass cover, all this particular heat would have passed to the environment. Okay? And then it would have become cold, and then if it is getting cold, it will not glow. So basically what we need is, we need a separation between our bulb and the environment. Why that is necessary? It is necessary so that heat will be retained. Okay? So it should be thermally isolated using insulating support. Okay? That is another point. So first thing we have insulated is with the help of glass material. But even at the bottom, it needs insulating support. What is the meaning of insulating support? Support in terms of insulator. Okay? So what kind of support we need? Insulator. So you can see this is the filament, right? And this particular support, the bottom support, this is totally made up of glass. Okay? And as you know, glass is an insulator. Okay? It's not a conductor, so it's a insulator, you can say. So basically for this filament we have used insulator support. So that is that insulator support, glass material. Okay, so this is the insulating support. Okay? So we are thermally isolating it, and second thing is it has insulating support. So both things we are satisfying here. Okay. Now another fact, that bulb is not empty inside. Okay? As suppose let's say everything is visible, you can see the filament right from the, suppose let's say outside. So many people think that there is nothing inside. So it is not the case. This particular case is filled with gases. Okay? So what kind of gases we can feel? So we can generally feel two types of gases. Okay? One can be nitrogen and argon. Okay? A combination, or even suppose let's say one can be sufficient. But there is one feature for this particular gas. Which gas suppose we should use? So technically we can use any gas, but it should be such a kind of gas which is chemically inactive. This is very important, chemically inactive. That means it should not react. Okay? It should not react. Let us see what will happen. Suppose let's say if we take some another gas, let us say some student is very much fond of oxygen, and when he was creating this bulb, he added oxygen in this. Now we will see what is going to happen. So electricity will be passed through this device. This chamber is filled with oxygen. For example, this filament is going to get heated. Okay? That particular heat is going to react with this oxygen. Okay? Oxygen will get heated, and that oxygen and that metal will create metal oxides. Okay? That oxygen and metal will create metal oxides. So basically that gas reacted with this, okay, due to the hotness. You already know that any chemical reaction can take place if heat is available. So we have to choose a gas of inside in such a way that it should be chemically inactive. React nahi karna chahiye. It should be something like a noble gas. You can use any kind of noble gas, okay? Or you can use nitrogen. Now many students think that why can we use nitrogen? It's not a noble gas, then why can we use it? Basically problem is that nitrogen is a very much stable gas. ठीक है, it's a very much stable. It does not generally react with some other gases. Hence, nitrogen is also a good option. ठीक है, so either nitrogen or argon you can use. And why to use them? It will prolong the life of filament. Filament is protected. We already have seen with the example of oxygen that if this particular thing is filled with nitrogen or argon, our devices will be safe. ठीक है, filament life will increase. That means suppose if we use oxygen, just it might last 6 months or 5 months because of the reaction. But if we use nitrogen argon, it might last 1 or 2 years. ठीक है, so we are increasing the life of a filament. Now, next thing, most power consumed appears as heat. This is the main feature. ठीक है, whenever suppose let us say these kind of bulbs are used, and if you put hands around it, ठीक है, whenever suppose you are using this kind of devices, do not touch it. ठीक है, these devices produce lot of heat, so do not touch them. But even if you go near them, ठीक है, even if you go near them, you can feel their heat. ठीक है, you can feel their heat. So basically all the electricity which we are supplying, all the power we are let's say supplying, that is appearing as heat. किसमें convert हो जाता है वो? All that particular power, that electricity power into heat, it is converted. Basically that is the operation. Okay, and small part of that power, ठीक है, small part of that power appears as light. So ठीक है, what light we are talking about? The glowing of the bulb, that light. So basically electricity was provided to it so that it should glow, but problem is that for glowing it needs to get heated. So that energy which we are supplying, it gets converted into two energies. One is heat, one is light, but majority of the electricity is going to be converted to heat in this electric bulb, and some part of our electricity is going to convert into light. ठीक है, so you should not forget about this. In the exam sometimes it is asked into which energy suppose let's say electricity is converted. So electricity is converted into two types. One is light, one is heat, but majority is converted to heat, small part is converted to light. That you should remember. Okay, now I hope everything is clear till electric bulb. It was a simple device. Now second device which we have is electric fuse. Same question they will be asking, how to suppose let's say explain electric fuse if it is used in suppose let's say electric current. ठीक है, if as a device, how heating is used in electric fuse, that is what we are going to talk about. Now before we proceed, let us just talk in general what is fuse. ठीक है, what is electric fuse? Electric fuse is a safety device. ठीक है, we all know these examples. Electric fuse, we have seen it from our childhood. What basically happens is whenever there is a lot of electricity flowing through our circuit, ठीक है, suppose let's say there is a lot of surge at our home, suppose let's say there is load or maybe there is a lot of electricity which is flowing through our home, then what happens is this device comes into play, electric fuse. So basically it protects our devices. ठीक है, whatever the electrical devices which we are using, this particular device, the small electric fuse device, like saves or protects our devices. How that is the case? So basically what it does is it stops the flow of high electric current through our devices. So for example, in case there is lot of electricity which is flowing through our home, so what this device is going to do is it is not going to allow that electricity to pass. So we will see, first thing what we are going to learn is how electric fuse is a security device. So electric fuse is nothing but our safety device at our home, electric fuse. So in short that we know, let us see detail, like how it does, what are the features, what it is made of, so all those things. Okay, now whatever I'm going to teach you for electric fuse, do remember that is there in our syllabus. Okay, so everything I'm going to cover is word by word from NCERT. So always remember that whatever I tell you is important from the point of view of exam. Do not skip any point. Okay, if I am telling you something, suppose let's say some topic from science, it generally means that it has importance from CBSE level. Okay, from terms of exam point of view, I'm not going to take anything which is not going to be asked in the exam. Okay, so don't worry, but focus on whatever I'm teaching. So just focus on this device. This is called as fuse. Okay, this is fuse. Actually it looks like this. Okay, it's a complete set. This is called as the top cover, this is the bottom cover, but we are going to focus more on this top cover. Okay, this bottom cover is just a, what I can say, connector, but this top part is important. So let us talk about that. So the top part is nothing but this particular material. This is porcelain, that we'll talk about. This material is made up of what? This gray material. But let us focus on this. These are made up of metals. Okay, these are metals, these are contacts. You can make them from copper or you can even make them from iron, it doesn't matter. But basically you have to see the other part. See, this is the side view of that particular fuse. Now let us see the bottom part. These are the contacts, right? These are the contacts. Now what we do is we generally insert a wire and we connect them to the two contacts. So okay, we start from this point and we take this wire and connect to the second point. This wire is called as fuse wire. Okay, that you have to remember. So this top part is called as fuse carrier. This top part is called as fuse carrier, and these are called as contacts. And whatever this wire is, that is nothing but called as fuse wire. Okay, this is actually the one which is very important, fuse wire. So let us start. So where the fuse wire is present between these two contacts, okay, that we know. So let me show you. This is the one I have marked it with red. So basically what we do is you fit a particular fuse wire in this particular case. Okay, so that is how you join it. All you have to do is open this screw. You can even do with your hand or even suppose it's a screwdriver. All you have to do is open it, attach that wire, okay, wound it up, take this wire from this particular central terminal and then join it to the second one. Okay, that's it. Your device is now ready. All you have to do is insert this particular device into this one, the bottom part. Okay, now let us talk about this. How to connect our particular device. So we have used our fuse. Okay, so it is already connected. Okay, we have already inserted our wire and we have put this particular cover into its box. Now let us see how it is connected in our circuit. So this is our device. Now that fuse wire is not visible from the top. Okay, that fuse wire is not visible from the top, but let me still show you. Actually, this particular wire is not visible from outside, but for our understanding, I am just highlighting it. Okay, this is just for understanding. You should not think that fuse wire is visible from outside. It is not. Okay, it is inside. Now let us connect it in our circuit. So this is from the top and bottom. I have connected two wires. Okay, these two wires I'm going to connect it to our battery and to our device. So I have taken two wires from the top. Now you might think from where these two wires are coming. So these two wires are coming from this point. See, this particular contact is with this, okay, and we are taking this wire from the top and the bottom. So two wires we are trying to connect. So let us start. So this is our fuse wire. Now I'm going to connect it to our battery. I have already connected to our battery. Now I'm going to connect it to our bulb. Okay, so let me put a bulb there. So for our understanding, I have used one bulb. Now let us see how electric current flows. So electric current will start from battery. Okay, that we already know. Electric current will start from that place. So electric current is starting. Now it is going to go to that fuse wire. Okay, it will pass through that fuse wire. Okay, and then it will reach to the upper part. So it has started from that fuse wire. It has reached to the top part. Then it is going to connect to the bulb. Now from that bulb is going to glow because electricity, it has received electricity. After that, it is going to the right side, after that to the bottom part, and then again to the battery. So this is generally the flow. How electricity is flowing is, it has started from the battery, then got to that fuse, then to the bulb, and again to the battery. Okay, so that is basically the flow. So let me show you again from the battery, fuse, then from the fuse to the bulb, and from that bulb to again to the battery. So that is the flow. Okay, general flow. Now let us see what if more current is flowing through the circuit. So let us just assume for a second that this particular battery has got damaged and it is supplying more electricity. So it should be supplying some kind of definite electricity, but due to some problem with that particular device, that battery, it is supplying more energy, more electricity than required. So let us see what will happen in that case. So our fuse is already there with our bulb. This electricity this time is too very high. See, in our example, what we are assuming is electricity which is flowing through our battery is very high. Now let us see what will happen. So it has started its journey in the same fashion in the last time. Now it is going to go to that fuse. Okay? But this time, do remember that this particular electricity which is flowing, it is very high. So what is going to happen is this particular electricity is going to pass through that fuse wire. Now this fuse wire is made up of such a material which has low melting point. ठीक है. So you have to understand that this particular fuse has a low melting point, this fuse wire. So basically one thing you know is that whenever electricity passes through any material, heat is produced. ठीक है. That is basically heating effect of electric current. That heat is going to be produced if electricity is passed through any material. So this is even if electricity goes through this material, heat will be produced. But we have selected fuse wire in such a way that it is made up of what kind of material? A material which has low melting point. Okay, a material which has low melting point. So when electricity is going to pass through it, this particular wire is going to get heated. It is going to get heated, but because of low melting point, it will melt. Okay, it has got melted because of what? High electricity. High electricity went through this wire, more heat was produced, and hence temperature increased, and because of the temperature this material melted. Okay, so what is going to happen? Our fuse wire is going to melt. Why that fuse wire melted? Because heat was produced. Okay, why that heat was produced? Because too much of current was going through this circuit. Okay, so as electricity increased, heat increased, and as heat increased, this particular wire melted. Now the current is not going to go through our bulb, so our bulb is saved. Otherwise, what would have happened? This electricity would have gone through our bulb and our bulb would have got damaged. So that is the case. Okay? So our bulb is safe now. So basically, fuse wire is nothing but this fuse, electric fuse, is a safety device. Now let us see how it is connected. So already we have seen that this electric fuse is supposed to be connected in series. Okay? We have connected this in series. Okay? One after the another. That the starting and ending points are different. It is not connected in two common points. So electric fuse wire here is this electric fuse has to be connected in series. Now let us just say, for example, what will happen if it is connected in parallel. Okay? That case we will also see. So in case of series, it is connected after the battery, right? Now let us see if it is connected in parallel. So in this case, what I've done is I have connected electric fuse in parallel with the bulb. So in parallel with the bulb, I have connected it. Now let us see what will happen if the electricity is flowing through this particular channel. Just consider that for a moment, electricity is very high. Okay, just consider for a moment that this device is again creating problems. Again, it is giving more electricity than required. Let us see the path. So it is going to start from the battery, going to reach this particular point. Now, as this particular channel is parallel, so what is going to happen? Electricity is going to get divided. Divided between whom? One is going to go in electric bulb, one is going to go in electric fuse. Okay? So this particular electricity has got divided. But you have to remember, this particular wire will get melted because this electricity is very high. Okay? So this electricity is going to flow through both the devices. Okay? Means even if this device melts, this bulb was not protected because electricity passed through it, even though this particular device was, suppose, let us say, got melted. So you have to remember that if you connect this particular fuse in parallel, it is not going to save our devices. You have to connect them in series. Otherwise, what is going to happen? That wire will melt. No doubt that wire will melt. But problem is that electricity will still pass through your devices, as in this case. So you have to always connect your particular fuse in parallel. That you have to remember. Okay? Sorry, not in parallel. You have to always connect them in series. Okay? That you have to remember. Okay. So this is the case. The case what I'm talking about, that what will happen if we are connecting it parallel. So this is going to happen. Electricity will come at this point. It will get divided. Wire will melt. But electricity is not going to pass through it. That we can understand. But you can see one of the branches of electricity was able to pass through our bulb. That means this bulb was not protected. Because in this case, our electric fuse was connected in what type? It was connected in parallel. Okay? So hence you have to connect your electric fuse always in series. They always remember this. Okay. Now let us see what this fuse wire is made up of. We already know one feature of this fuse wire is that it should be made up of low melting point. Okay, low melting point. First thing, it can be made up of metal or an alloy. Okay, it can be made up of any metal or any alloy. That is up to you. But basically what you have to maintain is it should have low melting point. That is the basic feature. If that feature is satisfied, any material you can use on this planet Earth. ठीक है? Fuse wire should be made up of such a material which is a metal or alloy, but it should have low melting point. Okay, so it should be made up of appropriate melting point. Appropriate means what? Low melting point, that we already know. Now what kind of examples you can take? You can take examples of aluminium, copper, iron or lead. But do remember, even if you use copper, now in many devices copper is used as a fuse wire. But problem is that pure copper has a high melting point. So what people do is, whenever they are using copper like thing in, suppose let's say in place of fuse wire, they generally use alloy of it. So none of the fuses which we use pure metal. Pure metal cannot be used, because if we use pure metal, it will have high melting point. It will never melt. Melt ही नहीं होगा. Our devices will be, suppose let's say, will get damaged because our fuse wire is not melting. So we need a material which is having low melting point. So even if you use copper, you have to use it as an alloy. ठीक है? Alloy of coppers. Now second thing, that fuse wire is usually encased in a cartridge of porcelain. This is very important. In the exam, this can be asked. This material, this gray material which you are talking about, this cream layer, okay, that material is called as porcelain. Okay, porcelain, Porcelain. So that is the material. In the exam, they will ask you, what is the outer covering of fuse made up of? So that is called as porcelain. And this is something like, you even must have heard this word at your home. Porcelain utensils are used in our kitchens generally. It is something like, looks like china clay, but there is a difference. Okay? So basically these materials are used for making crockery, suppose, and these are insulators. These are not conductors of electricity. So it is very simple for us to use these devices because these are insulators. Okay? Porcelain material is used to make them. Now you might say, sir, why not use plastic or why not use glass? You have to remember that you can use them. It is your choice. But problem is that those devices are very delicate. Those devices can break, and these electric fuse are our safety devices. We expect them to last long. It should not break. Otherwise, what will happen if it is made up of glass and suppose let's say it got broken, or maybe suppose let's say somebody threw a stone at it or whatever happened, and if it got broken, okay, if it got broken, easily it will break, okay, if it is made up of glass, and our devices will not be protected. So what is suggested is that you use material called as porcelain, as it is very, very much durable. Are you have no idea how much tough this material is. This porcelain can be, suppose let's say, it can remain for 100, 200, 500 years. It doesn't, suppose let's say, weather. It's a very good and tough material. Okay? So which material has to be used? Porcelain. Okay. Now last point which we are going to discuss is fuse rating. Okay? Fuse rating. Now what is fuse rating? So that is nothing but maximum current a fuse can withstand. So whenever you go in the market and suppose let's say if you ask them, Bhaiya, please give me electric fuse. So what he will ask, what kind of fuse rating you want. So fuse rating is nothing but that is the value. Suppose let's say these are the fuse ratings which are given. 1 ampere, 2 ampere, 3 ampere, 5 ampere. What is the meaning of this? Suppose let us say that shopkeeper has given you electric fuse of 5 ampere fuse rating. So fuse rating means nothing but it gives you idea how much electricity can pass through that fuse. So for example, if you are taken from the market, suppose this is the device and the shopkeeper said that fuse rating of this device is 5 ampere. It means that it can withstand 5 ampere current. So if current increases more than 5 ampere, this wire will melt. That is the meaning of it. So what is the meaning of fuse rating? Fuse rating is nothing but it is the value given in ampere. First thing, it is the value given in ampere. And it gives us the idea how much electricity can pass through our fuse. So that is basically the definition of it.